In this video, I'd like to talk about the math question of the day for February 13th, 2023. And for this problem, we need to simplify this product here. We're multiplying these two complex numbers. And remember that I is just the square root of minus 1. This is the imaginary unit. And to answer a question like this, you need to have a solid understanding of complex number arithmetic, particularly multiplying, adding, and subtracting complex numbers. And that is typically something that you might see in Algebra 2. So at this point, go ahead and pause the video and see if you can work through this on your own. Now, assuming that you have attempted the problem, we can start going through this together. And if you do have suggestions for future videos, feel free to leave them as a comment down below. Now, when we have two complex numbers and we multiply them together, we essentially would multiply them the same way as if we had two binomial expressions and let's just say everything is a real number. So x represents some real number that doesn't have I. When we multiply these two binomials, we use distribution. The x goes to both, the 1 goes to both. We get x squared minus 2x plus 1x minus 2. And of course, we can simplify this. But the general idea is that multiplying complex numbers works almost the exact same way with one slight modification. And if you do want to understand these complex numbers better, remember that you can plot these points on the complex plane where the horizontal axis is a real axis. So these are counting off the real numbers. Let's say we're going to plot this one. So we need to go to minus 3 for the real axis. And then the vertical axis is the imaginary axis. These are going to be multiples of the imaginary unit, I, 2i, 3i, and so on. And we need to go down to minus 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this point right here, which we can do in this color, would be on the complex plane at minus 3 for the real part and 9, or negative 9, I for the imaginary part. So this number is just this point on the complex plane. This 1 plus 10i would be 1 over, and then up 10, that would be somewhere up there. And the arithmetic of actually multiplying these together, like I mentioned, is fairly straightforward. We just apply this distribution. However, and I should mention that this is a different point so that our colors match up. However, when multiplying complex numbers, there's also a geometric interpretation. And I won't go through all the details, but it is nice to know this so that you can have a better intuition of what's going on. And all complex numbers we can plot on the complex plane here. And these numbers are at a certain distance from the origin, which we call the modulus, or absolute value of the complex number. And they also are at some angle, we can call that theta, from the positive real number axes. And likewise, we can do the same thing for this point right here. Let me use a different color for that. This angle theta, though, keep in mind, is always going to be measured from the positive real axis. So we can call that, let's say, theta 2, where this is theta 1. And again, it will have some distance from the origin here, some absolute value or some modulus. And when we multiply these complex numbers together, what happens is that in our product, we would add these angles. We would take theta 1 and add theta 2 to that. And that looks to be maybe somewhere down here. It's going to be hard to perfectly estimate it, but let's say it's about that angle. And the lengths, the magnitudes of the two complex numbers, these distances from the origin, those will multiply together. So if we multiply this distance here, which is just bigger than 10, and this distance here, which is about 9.5, if we multiply those together, we get roughly something just under 100. So the product of these in its geometric interpretation would have an angle in this fourth quadrant, but its point would be out at a distance of around 100 away from that origin. So that's another way to interpret these, using this geometric interpretation, and it is a nice interpretation. You just add the angles and you multiply their magnitudes. But for our purposes, we just need to carry out the arithmetic. This just helps give a little bit more intuition for what's going on, since complex numbers can be a bit mystical. So we will start by distributing the -3 to both, and then the -9i to both of these, so that our final result then will be -3 times 1, which is -3. We have -3 times 10i, which is -30i. -9i times by 1 would be -9i. And then we have -9i times by 10i. So 9 times 10, or -9 times 10, would be -90. I times by I, that would be I squared. So we need to figure out what is I squared. And if we know I is the square root of -1, when we square both sides, we're taking the square of a square root, and that will cancel, and we just get back -1. So this I squared is simply -1, and we can replace it there. And we can also combine like terms so that we get -3 minus 39i, and this will just become -90 times by -1. -90 multiplied by -1 would be +90. And we could combine like terms again. We're looking at the real parts, -3 and 90, that is 87. And we have -39i for the imaginary part. And based off of this brief introduction into the geometric interpretation of multiplying complex numbers, this answer matches up with the answer we found there, though it's hard to see that exactly. We would go over 87 and the real part, so way to the right, and then down 39 in the imaginary part. But the general idea is that it will be in this fourth quadrant, and if we calculated its magnitude, its distance from the origin, we're essentially just looking at the Pythagorean theorem, then we can actually find that distance. And what we'll see is that this is just under 100, which is what we expected. This is approximately 95.34. And when looking at this scaling of this length multiplied by this length, we determine it would be roughly just under 100. So this does make sense. And this will just give you a different way to verify your results using this more intuitive approach.